Hello everyone, my name is Hemu and I am from Skilled Inspirational Academy, which is CNET, and we are going to start one of the batch on Palo Alto Firewall. So we will first cover your entire Palo Alto Firewall concept. Then we will basically start your panorama. We will also cover your expedition tool like migration of different firewalls like ASA to Palo Alto migration, Checkpoint to Palo Alto migration, or Juniper to Palo Alto migration, or like Palo Alto to Palo Alto migration. So we will basically explore here expedition tool, and we will also explore the Palo Alto and the Panorama API. So whenever we will make bulk changes, we can do lots of cool things using the API. So that I will cover. And guys, it's a weekends batch as I have mentioned here. And we are starting from 8th of December. And the class timing for this particular batch is 9 a.m. IST to 1 p.m. IST. So it's around we have around 4 hours of sessions where we will take a 30-minute of break in between. And guys, if you are really interested for this particular training, these are the contact numbers where you can reach out to us. First number belongs to me and second number belongs to Bidit sir. So you can reach out any of these numbers. Now, before starting, let me just share a couple of details. So guys, if you want to purchase our recorded sessions, so you will find all our recorded session into our video portal, and the URL is learn.crnets.com. You will go into the courses section and you can able to see everything. So we have a multiple courses here on Palo Alto, like we have a Palo Alto Firewall, Panorama, Palo Alto Advanced Troubleshooting, AWS for network engineers, Azure for network and security engineers, F5 LTM, GTM, ASM, Python for network automation. Multiple courses are there, so you can check out. This is our website, cnets.com. We have a two YouTube channels. First, with the name of cnets.com, where you will get lots of videos on Palo Alto Firewall, Panorama, AWS, Wireshark. We have another channel with the name of Skilled Inspirational Academy, where also you will get lots of videos on Python, F5 LTM, GTM, ASM, right? So these are our details. You can check out these particular YouTube channels or our website if you want to know more about us. Now, let me go through what are the things we are covering in this particular training. So guys, in this training, it's around 90 hours of training. So where around 50 hours of discussion I will do on Palo Alto Firewall. Then remaining 40 hours of discussion I will do on Panorama plus API and Expedition. And like I'm not a time limit, basically if required, we can go ahead as well, like 90 to 100 hours as well. That's not a problem. You will get the lifetime interview support from our side. So if you have an interview, you can reach out to us. We will help you. We will take your mock interview as well. You will get the documents. After this particular training, also you will get the training certificate. We will also offer you the lifetime access of recorded sessions. So if you will enroll for this training, you will get the access of recorded videos with lifetime for this particular batch. It's a weekends classes, Saturday and Sunday, and during the session, you can also able to discuss any type of practical issues if you are facing in your lab, and also if you are facing any issue in your production environment. We will offer a mock interview support as well. And this particular batch, as I have mentioned, is starting from 8th of December. So these are the things which I'm covering in this particular training. Now let me just discuss today's topic, or what I see guys, I will let me just go through with the course content, but here I will not discuss course content in detail. I'll just give you the overview of it. And after that, I will focus towards today's topic because it's a bit long topic, around 3 hours I needed, but I will try to bind up in around 90 minutes. Let's see how it will go. So let me just go give you the overview of our course content. So, in Palo Alto Firewall, I will start your discussion with the platform and architectures. We will understand what is SP3 architecture, what is the packet flow or flow logic, right? How we can make the initial configuration. Initial configuration includes your management settings like IP address, how we can configure IP address in the management interface, how we can configure DNS, NTP, right? Host name, domain name, certificate, all these things comes under the initial configuration. Then initial access of the system, how we can get it. Configuration management, where we will discuss what is the candidate config, what is running configuration. Like we have a different configuration management options, like we can revert the configuration, load the configuration, import, export, all these things we will discuss in detail. I will also go through with the commit here, like commit phase 0, phase 1 and phase 2, how it works, what is the how it is involved with the management daemon, and how it is involved with the config daemon, right? Everything I will cover. We will discuss licensing software updates here, like what are the license offered by the Palo Alto firewall. So I will go through with each and every detail. How we can register these Palo Alto devices into support portal. So this is also I will cover. Then account administration, how we can create a account or like local admins in your Palo Alto firewall, how we can set the password complexity for them. Everything I will cover, and what is the best practice basically we have to follow. So this is also I will cover. Guys, I hope I'm audible properly. I'm getting one message from one of the student. I'm not audible. Just guys confirm on the chat if I'm audible properly and my skin is visible to everyone. Hello. It's fine, right? Just give me 1 second. I think Charu is here. Okay, Mushkan is here. I'm making her co-host. Okay, Mushkan, just take care of the chat. And guys, I'm not looking much in the chat. So if you have any questions, I'll take after the demo. Okay.
Okay, sir.
Then guys, we will discuss the account administration, how we can integrate with the Radius server, what is the admin roles, how we can create a different roles for different admins, then interface configuration, security zones. We will do the practical lab on layer 2 deployment, layer 3 deployment, VUI deployment, tap mode deployment, what are the benefit we are having on these deployments, everything we will cover here in detail. Then we will discuss the concept of sub interfaces, and also we will do the practical for aggregate interfaces. And guys, for this training, I am using one of the hardware device which is PA440, and I have also purchased couple of Cisco switches which is 3750 series. Okay, so we will do all the hardware related practicals as well whenever required. We will discuss the DSCP option, what is DSCP client, server and relay option we are having in Palo, then virtual routers. We will see the multi-VR setup as well, right? Then we will discuss security policies and net policy in detail. So like security, everything I'll cover in security policy, even though I will also explain you how you can do the rule optimization, right? Then net policy, net rules, we will do most almost around 7 to 8 8 practicals basically on source net, destination net. In destination net, we have a multiple use cases like destination net one to one, then one to many, port forwarding, right? So multiple things we will perform in your net policy and security policies. Then we will discuss the app ID. In app ID, we will configure everything like application override, how it works, how we can create a custom application, then app ID, overview, application group and filters, right? Everything we will discuss with regards to app ID, how application shift work, basically, how PANOS basically do the app identification for TCP based traffic and for UDP based traffic. So everything we will cover here. Then content ID overview will do the practical for antivirus, anti-spyware protection, vulnerability protection, URL filtering, external dynamic list. And guys, these particular practicals we will do live because I will launch lots of attacks from my Kali Linux machine. I will create a virus, malicious payload, and I will try to download that payload, and we will see how firewall is protecting us. And if we have allowed the traffic through the firewall, how we can basically gain the access of our internal servers through that Kali Linux machine, how we can launch these attacks. Everything we will cover. And URL filtering, we will do lots of practicals lab. We will block lots of websites. We will allow lots of website, and we will see how URL filtering works in actual. How basically cache is maintained for URL filtering, right? How Palo Alto connect with the PanDB URL filtering database. How it will do the query lookup for URLs. Everything we will discuss. Then external dynamic list we will cover in depth. Then file blocking, your wildfire practical, security profile file blocking, right? Then we will discuss zone protection and DOS protection. Here I will launch the TCP SYN flood attack, UDP flood attack, right? Other IP flood attack or ICMP flood attack. I will launch the host spoofing attack, and we will see how zone protection and DOS protection protecting us. Then we will discuss the SSL decryption. Here I will give you the very in-depth overview of SSL, right? Then how SSL decryption work, how certificate works, how SSL handshake, outbound SSL decryption, inbound SSL decryption, we will discuss in detail. Then most important part, which is SHH decryption, because most of the time nowadays people used to basically make a SSH tunnel, and they used to basically send any type of traffic through this SSH tunnel, right? So how we can basically protect from such type of tunneling attack? How we can enable the SSH decryption as well in your firewall? And we will see all these things with practicals. Then your user ID related practicals, how user ID works. Then we will integrate our Active Directory, right? User to IP mapping, user ID agent, how all these things work with regards to user ID, how I will basically install one AD server on my lab basically, and I will create a multiple users and multiple groups, and according to their users and groups, we will configure like they can this like HR department peoples can able to access the job search site, but they will not allowed to access the like social networking sites. So these type of things we will do with practicals. We will discuss the captive portal, right? How captive portal works for Linux machine or for Android machines and all. Then site to site VPN, how phase one and phase two actions happens, and IPsec site to site VPN, very in-depth discussion we will do, even though I will basically decrypt all the type of messages of IKE version 1 and also IKE version 2. All these messages we will decrypt, right? ESP packets also I will decrypt. I will tell you how you can take out these particular session keys, and we will see everything how this exchange works. We will validate each and everything, like how message number one, message number two exchange, then how your DH exchange works, how your how basically this message number 5 and 6 exchange for identification, then how your quick mode happened, everything we will discuss. And I have mentioned here around 13 use cases, and all these use cases we will discuss. So for some of them you will get the recorded session. For these use cases, some of the use cases I will cover in your session. Then we will discuss global protect VPN. In global protect also we will basically decrypt your global protect related packets. We will go through with the connection flow, because if you know the connection flow, you can able to do the troubleshooting. Otherwise global protect troubleshooting become very difficult. We will discuss the global protect connection methods, how we can configure the user logon method, then on demand method, then pre logon on demand, and pre logon user logon. All these four methods we will discuss with practicals. We will see the integration of your syslog servers, your NetFlow servers. We will discuss the log type, dashboard, basic logging, right? Then active, passive, high availability, active, high availability, right? Active, passive. Here I will also discuss the advanced architecture of HA, how HA agents communicate between both the firewalls, how system daemon communicates between both the firewalls, what are the information they will synchronize through HA1 link, through HA2 link, everything we will discuss. We will do the floating IP HA lab, ARP load share HA lab, mixed mode HA lab, everything we will cover. So this is what I am going to cover with regards to your Palo Alto firewall training. In your panorama training, basically, I will go through with the panorama overview, understanding of Palo Alto firewall, understanding of panorama deployment methods, how we can set up the panorama lab. I will go through with the panorama commit walkthrough, how commit works with regards to panorama, because when you will push the configuration through panorama into your firewalls, most of the time you will face the issues like your commit is failed, your management server is hanged, right? How we can identify all these issues? So we will go through with the commit walkthrough process, like what is the job schedulers we are having inside your Palo Alto firewall, right? How this phase 0, phase 1 and phase 2 works, how validation happens, everything we will discuss. Then panorama management plane overview, and management plane troubleshooting. We will discuss each and every demons, how it works inside the panorama. Because if you are not aware of that, this is the daemon architecture of Palo Alto Firewall. So we have a similar type of daemon architecture inside your panorama. So we will discuss how these demons communicate with each other, how panorama maintain that particular logic. Okay, so we will discuss in detail this particular management related information in your panorama. Then we will discuss how we can manage multiple firewalls using panorama. We will see the onboarding of your firewalls into the panorama, right? How the secure communication works. We will see everything in detail. We will check the logs of management server and config the daemons, how they are communicating, how validation happens, everything. License management, software updates, dynamic updates of panorama and firewalls, right? How we can manage the software updates and dynamic updates, right, of firewalls through panorama, how this communication happens, right? So we will see everything with practicals. Then we will discuss the device group, where which includes your policies and object, how we can create a different type of security policies, net policy, decryption policies, application override policies, how we can create different type of objects through panorama, right? Like address object, service object, your layer 7 profiles, everything we will see. And we will also see here what is the best practice for that. Then panorama template and template stack, which includes your network and device related configuration, right? We will create a different type of templates for branch office, different template for head office department, different templates for your dia firewalls, everything we will see practically. Okay, then we will do the onboarding of HO, head office firewalls, and branch office firewalls. We will configure the security policies and all. Then we will do the SSL decryption, app ID, content ID configuration, IPsec, VPN, global protect configuration. We will see the panorama HA. So guys, in panorama, I am going to deploy two panorama as a HA pair, and I will deploy two panorama as a log collector. So it's a very nice lab which I'm going to create with regards to panorama. Then we will see the upgrade and downgrade of panorama and your firewalls, how we can install the software updates, everything. Then log forwarding and collections, administrator accounts, aggregate monitoring and reporting, panorama use case, like how we can basically, let's suppose you are managing your firewalls locally right now, then how we can onboard that firewall into the panorama with all the policies and all, right? So we will see that if let's say you are managing some firewall through panorama and you want to start managing them locally, then how we can basically do that job as well, right? Then we will do the basic troubleshooting on panorama CLI, then expedition tool setup, panorama and firewall integration with expedition tool, then ASC to Palo migration, Juniper to Palo, checkpoint to Palo Alto migration, then panorama rule bulk config change, and exploring the panorama API. This is what I'm covering with regards to panorama. This is the detailed course content, guys. What I will cover in what section, so everything I mentioned in detail. So you may request for this course content. We will share you through our numbers. Okay. Now, guys, let me just discuss today's topic, which is like life of a packet in Palo Alto, or like life of a packet inside the PAN-OS, or like what is the flow logic inside your Palo Alto firewalls, or the packet flow in Palo Alto firewall? So these are the different names, and this is the most asked interview question, right? If you will go for any of the interview, definitely you will face this particular question. And I know most of you are the experienced peoples, right? And you must have faced that particular question in your interviews as well, right? So let me just explain you this particular packet flow, how it works. Before going into this packet flow, guys, I am going to tell you the little bit details with regards to Palo Alto architecture. So in Palo Alto firewall, basically your PA firewall, what they have a architecture, right? So in their architecture, they have a management plane separate, and they have a data plane separate. They have a separate data plane and they have a separate management plane. Like here you can see hardware level, they have a segregation. So this is your management plane, and this part is known as data plane. Now in your Palo Alto firewall, it has further divided its data plane into three another planes: network processor, security processor, and signature match processor or data signature match processor, or the pattern match processor. So this data plane is also further divided into three another plane. Just remember that part, guys. And if I will give you the idea about the daemons level, so what they have done, there's a one daemon called master D. So this master daemon is a part of your management plane, and one core of master daemon is running inside the Palo Alto firewall data plane, and one core which is available inside the management plane. And this master D has a communication with the system daemon, and almost all the daemons which are available in your data plane and the management plane, they are connected through the system daemon. So this is a mother daemon inside your Palo Alto firewall. So whenever any user send any type of traffic, that particular traffic is handled by the data plane. And these are the data plane daemons like Pentask, Supervisor, PenDHA, EHMON, BRD agent, Imperial agent, PenCom, then SysD agent, your tunnel D, right? These are the main daemons in your data plane. So like we have a data plane and we have a management plane. Now, as I have mentioned, this data plane is further divided into three another plane. So let's discuss how it is divided basically. So, if you will see this particular diagram, this is the actual data path of your Palo Alto firewall. And I am basically discussing about the PA5200 series boxes especially. So, if you will see this particular area from here till here, this is the actual data plane of your Palo Alto file. And as I mentioned, this data plane is further divided. So they have a network processor. Then they have a security processor, which is also known as DP CPU or data plane CPU. So like in 5200 box, we have a three DP CPU. So DP0, DP1 and DP2. And they have a signature match processor. So this is the signature match processor. Now, this signature match processor is responsible for two tasks, which is your app ID and content ID. All your layer 7 related task is done by the signature match processor. And in this signature match processor, they have a chipset which is known as CE100. In the 5200 series box, they are using CE100. Previously, they were having 5K series. On 5K series, this chip is known as a Jaguar chip. This was the name of that hardware chip. It's a ASIC or a FPGA, right? And this network processor, they are using FE100 chip. This is also act as a session offloaders. We will discuss this what is session offloading in all in detail. And this is also a FPGA like field programmable gateway array. It is some type of hardware chip which can process the packet at layer 2 to layer 4. Then we have a main chip of Palo Alto firewall, which is a Octeon chip. And this is a chip who is going to handle all your packets. All your packet is handled by this Octeon chip. This is the data plane CPU and it's a multi-core chip basically. Multi-core chip means we have a multiple like a 64 core here, 64 core here and 64 core here like that. Depend on the hardware platform. And before that, we have a one more chip, which is known as Qumran chip. And all your interface, like either your fiber ports or either your copper port, they have a direct connectivity with this Qumran chip. And this Qumran chip has a direct connection with the FE100 through this particular link. These are the high speed fiber links, and these links is known as joy links. These are the joy links. These are the high speed links. So whenever packet move from one chip to another chip, these are the links who will basically help you, who will help in moving that particular packet. So this is the latest data path. And guys, if you have any problem in the data path, let's suppose one of the chip is not working properly. Maybe this chip, this is just a hardware, right? It can become faulty. Let's say this chip has a fault basically. Some type fault is there, it is not able to process the packet. Then there is a there's a proper troubleshooting approach for that, and we have to follow that approach. Then only we will able to find that particular issue, and we have to do the RMA after that. In old, basically, let me just go here and In old firewalls, basically this was the architecture. Instead of Liger and Tiger chip, we will be having Liger and Tiger chip, which is replaced by the new processor, which is FE100. Right? And you know, this Octeon is similar, and this Jaguar chip is basically replaced by the CE20, right? Because the name I am not remember. Let me just get it. It's CE100 because in some models you will see CE20 as well. C100. Okay, so this is a Jaguar chip and responsible content ID and app ID. Like there's a multiple things are there, but we will not discuss in detail. And you know this, if you will see this diagram, like Palo Alto data plane is divided into signature match processor. This is the Jaguar chip basically, or in latest boxes, it's a C100 chip. Security processor, we have a Octeon chip. In this Octeon chip, we do have a dedicated chip for SSL functions and dedicated chip for IPsec functionalities and dedicated hardware component for decompression. Okay, and we have a network processor where we have a Liger or Tiger chip. In latest boxes, you will be having a FE100. Okay, so this was the overall architecture of Palo Alto firewall. In details, we will discuss in your live sessions. Now let's discuss the Palo Alto firewall packet flow. And guys, I'm going to cover the latest packet flow basically according to the PAN-OS 11.1 series. Okay, how the packet processing happening and all. So you know guys, whenever, let's suppose we have a setup like that. Let's suppose this particular user initiated some of the traffic towards this particular server, this DC server, right? So when he will initiate this traffic, so this traffic first go to this router, then this router, and after it will basically go inside the Palo Alto firewall interface Ethernet 1 by 5, right? When this traffic received by the Palo Alto firewall on Ethernet 1 by 5, what it will, it this particular packet will go through couple of stages. It will go through with the packet processing stages. And you know, this particular packet will go through with the ingress stage, session lookup or the flow lookup stage, slow path, which is also known as session setup stage, then fast path, which is known as like layer 2 to layer 4 security processing, then app ID, then content ID, then forwarding stage. So these are the stages basically where each and every packet needs to go through with that. So whenever we receive a packet, these are the stages where packet generally go. Now, let's try to understand what happens in the ingress stage. So just remember these are the 7 stages basically. So you know, when we receive a packet into the ingress stage, let's say we have received a packet inside the your Palo Alto firewall in the ingress stage. So what will happen now? After receiving this packet, my Palo Alto firewall basically put this packet into the ingress stage processing. And what it will do, it will extract the layer 2 information, layer 3 information, and layer 4 information from the packet. What it will basically start extracting, or I can say it will just parse the information at layer 2. Then it will start the parsing of that packet at layer 3, and it will parse the packet at layer 4. Right? And what it will do, it will also perform the ingress interface lookup and source zone lookup, because we know this packet we have received on Ethernet 1 by 5, and we know this Ethernet 1 by 5 interface is a part of inside zone. So the main function of This particular layer 2 parsing is to basically get the ingress zone detail or the source zone detail. When it will do the parsing at layer 3, what it will try to get the source IP address, destination IP address, and the layer 3 protocol number. And at layer 4, and when it will do the parsing, it will get the source port details and destination port details. Sometime we receive the fragmented packet, so it will do the IP reassembly. It will create a proper packet, and once packet is created, it will again start the parsing, but this time it will start the parsing from layer 3 onwards. And if you want to see what happens in the parsing level, so let me just open one of the debug file actually. Just give me a second. So you will get the whole idea. Okay, I do have one debug here. Yeah. And we will discuss all these details in depth basically in your live sessions. Okay. So, if you will see here, I have mentioned we have received a packet inside your Palo Alto firewall at ingress stage. Palo Alto firewall used to assign a work queue index. Basically, this is the index number. And it has start parsing the packet, and at layer 2, it has get the source MAC details, destination MAC details, and ether type. Ether type it will get because when we will start parsing at layer 3, we have to know it's a packet, IPv4 packet or IPv6 packet. Then it will basically do the parsing of layer 3 header. And it will get the source IP detail, destination IP detail, protocol number, version details, header length, toss field length, right? Fragment offset, TTL value, checksum value, all these details. Then it will basically extract the packet at layer 4. Source port, destination port. This is the sequence number, acknowledgement number, right? It's an entire TCP header, right? These are the TCP options. And after that, once this particular English parsing will complete, it's moving towards the flow lookup, which is the next stage, right? So this is how your packet is processed inside the Palo Alto firewall at ingress stage. But at the ingress stage, there is a couple of other checks also happens. Once it will complete the parsing, now what will do now Palo Alto firewall basically check the packet towards the ingress process errors. What do you mean by the ingress process error? Let's suppose there is a one of the hardware developer who has done some violation where when he has designed the layer 2 Ethernet header and Ethernet header is malformed, or your layer 3 header is malformed, or layer 4 header is malformed, right? Means if there is any type of protocol violation, then this is an invalid packet, right? So this type of packet it will detect and it will drop these particular packet. Let's suppose we are receiving the fragment packet, but we are receiving these fragments out of order. Or let's suppose out of 4 fragments, we are only received 2 fragments. 2 we have lost, right? So such type of packets, it will basically drop at your ingress stage itself. It will check these particular packet for all that. So it will check for ingress process error. If there is a error, then it will discard the packet right away. And guys, if your firewall is discarding the packet due to this ingress process errors, and if you will check your traffic logs, you will not see any type of injuries. Then how you will troubleshoot? So you have to take the help of global counters. With the help of global counters, only we can able to troubleshoot such type of issues. We have to take the packet captures and we have to look the behavior. Sometimes your packet also drop by the Palo Alto firewall because it used to maintain the DOS block table. And if your IP address and the zone details, so let's say we have received a packet and that particular source, that particular user's IP address is there in the DOS block table, then it will discard that packet right away. And how it will basically maintain this DOS block tail? Let's suppose somebody has launched the IP spoofing attack, or the host sweep attack, or the SYN flood attack, or the UDP flood attack, right? So such type of IPs firewall used to put into the DOS block table, and it will basically, if we will receive subsequent packets for that, it will drop that packet right away. And after it will check firewall inspection applicable, means let's suppose we have deployed Palo Alto 5 in tap mode. In tap mode, inspection is not applicable. But here I'm considering we have deployed in layer 3 mode. So your packet now go for here in next check, and they will check is whatever packet we have received, is this packet belongs to the IPsec VPN or the SSL VPN or the GRE tunnel packet or the SSH traffic. If we are receiving such type of traffic, if yes, then in case of IPsec packet, what it will check the integrity, which is hash. It will decrypt that packet, it will do the decapsulation, and it will get the final internal, and it will get the final packet basically, right? Because all the packet starting from layer 3 to layer 7 is encapsulated by the ESP header, right? In case of IPsec, right? So once it will get the actual IP header, it will put this packet again for the ingress process. And here parsing start from layer 3. Same with SSL VPN, it will check the hash, decrypt it. In GRE, hash check and decapsulated. In SSH, hash check and decrypted. And after it will put this packet again into the ingress processing. So guys, these are the tasks which is performed by the PAN-OS or Palo Alto Firewall in the ingress stage. Now let's try to understand all these tasks in detail. So when we receive a packet in your ingress stage, receive packet from the network interface, parse the packet and determines whether given packet is subject to the firewalling or not. If packet is subject to firewalling, then continue with the firewall session lookup and enter the security processing stage, otherwise forward the packet. Packet may be discarded due to the protocol violation. Firewall attack prevention features may discard the packet. This is a DOS block table one. Packet without configurable options, because those packets would eventually be discarded by the end host anyways. Let's go down a little bit. Now your first thing, it will start the parsing at layer 2, layer 3 and layer 4. Information extracted and ingress interface source lookup has been done here. Now protocol parsing start at layer 2. So what it will do, generally we will have a frame at layer 2. So it will parse that frame, and PAN-OS extract the source MAC and destination MAC and the ether type. Packet parsing start with layer 2 header of the packet received from the interface. And sometimes let's suppose we have a sub interfaces. Generally, we will receive a packet on Ethernet 1 by 5. Let's suppose on this Ethernet 1 by 5, we have a multiple sub interface like Ethernet 1 by 5.10, Ethernet 1 by 5.20. Let's say these are two sub interface we are having. Or let's say we are having aggregate interface where we have Ethernet 1 by 5 and Ethernet 1 by 6. These are the aggregate interfaces, right? Then what it will do the ingress port lookup. 802.1q tag and destination MAC address are used as a key to do the lookup for the ingress logical interface. Means it will get the final logical interface as well and the final zone. Maybe Ethernet 5.10 is a part of inside zone and 20 may be a part of DMZ zone, right? So the main objective of this particular lookup to get the ingress zone. Okay. If interface is not found in the packet or packet is discarded, then you have to check the receive error counter and the global counter. And this is the command to check these counters. Let me just log in on my firewall. Oh, both access I lose. Oh, this is a switch, sorry. It will take some time to come up. The command is better. I can show here only. Show counter global. And here you will see we have this packet receive. This is the one which we have to check. So all these particular checks are there, right? With regards to flow, we have a lots of checks here. If interface will not found, then this is the counter you have to check. Okay. Now basically they will start the parsing at layer 3. IP header is passed and Panos extract the source IP and destination IP. And you know, sometime you will see the header violation or the IPv4 packet is discarded due to following reason, like mismatch of ether type and IP version. Let's suppose on Ethernet header we have seen the ether type for IPv4, but in actual when firewall did the parsing, it sees IPv6, then it will drop that packet right away. Mismatch of ether type and IP version. Truncated IP header. Let's suppose someone has removed some of the mandatory field from the IP header, then this packet has been dropped. If we are receiving the packet with IP protocol number 0, then also your packet will be dropped. If we are receiving the packet with TTL which is 0, then also your packet will drop. Land attack packet is also the means if source IP equals to destination IP. Means we are receiving the packet from 10.1.1.100 and it is destined towards 10.1.1.100 only. Then this is a land attack. And this type of packet is also dropped by the firewall. Then ping of death packet, marginal IP address. So such type of packets generally drop by the Palo Alto. In case of IPv6, mismatch ether type IP version, truncated IPv6 header, truncated IP packet. These packet is dropped in case of IPv4 and IPv6. At layer 4, basically, they do the parsing for TCP, UDP, ESP, GRU, ICMP type of packets, right? TCP packet is discarded if we are receiving TCP header is truncated or the data offset field is less than 5, checksum error, port is 0, invalid combination of TCP flag. Guys, tell me one thing. Are you able to see SYN flag equals to 1 and FIN flag is also 1? This is totally a invalid combination. Such type of packet is also dropped by the Palo Alto firewall right away. UDP header, like UDP header truncated, payload is truncated, or UDP buffer length less than UDP length field, or checksum error, right? Such type of packet has been dropped at the UDP level. Then IP fragment reassembly if required. Sometime my firewall also do the reassembly of the packets if we are receiving the fragments, and if we are receiving fragments like out of order, which is known as, or there is some overlapping fragment which is also known as like teardrop attack. So thus this type of fragment packet is also dropped by the Palo Alto firewall. Then we have ingress processing error. DOS block table it will check, and if basically we have any IP into the DOS block table, it will drop that packet. And this is the command debug data plane show DOS block table. You can able to see that particular table. Debug. Debug data plane show DOS block table. You can able to see that particular IP address there. So in your zone protection and all, I will cover that particular scenarios where you will see. You can remove the specific IP address from the DOS block table, right? All these details you can check. The internal decapsulation we have already seen. Once all these tasks is completed, now your packet go into the flow lookup stage. So guys, now let's try to understand the flow lookup stage. So you know, in ingress stage, basically, what used to happen, let's suppose we have this PC1. This is your firewall and this is your server. Very hypothetical I'm going, and for PC IP is 10.1.1.100. Server IP address is 10.2.2.100. This interface Ethernet 1 by 2 and this interface Ethernet 1 by 3. Let's take an example. This is my inside zone. This is my DMZ zone. Let's suppose from this PC, we are taking the SHS access of this particular server. Okay. So what used to happen that time, this PC will send a packet towards this server. So that time basically Palo Alto Firewall extract the information like source IP address, which is 10.1.1.100, destination IP address, which is 10.2.2.100, source port, random port 1035, destination port for SHS, generally it's 22. What is the layer 3 protocol number, guys, for TCP? Write on the chat if you know the layer 3 protocol number for TCP. It's 6. And the source zone. Source zone is inside. These are the 6 tuple, or these are the 6 fields which is extracted in your ingress stage. And what it will do now, when your packet reach to this particular flow lookup here, when it reaches into the firewall flow lookup match, what it will use these 6 tuples which is extracted at ingress stage to, and it will basically using these particular 6 tuples, it will basically do the lookup into the flow table or the session table. What it will do? It will do the lookup into the flow table or the session table. It will do the lookup into flow table and the session table using the 6 tuples. And how it will do? It will take these 6 tuples. It will basically run the MD5 hash on this particular source IP, destination IP, source port, destination port, layer 3 protocol number, and inside zone. And it will do the lookup into the flow table. Because we know it's a first packet, and generally first packet is a SYN packet. And if it's a first packet, then there is no flow. We will not found any type of flow. So it will do the flow lookup into the flow table. If there is no flow, then it will move this particular packet towards the silo path or firewall session setup stage. Let's suppose we have received a packet for that flow is already exist. If yes, then you will see here like flow state in session table means for this particular packet there is a entry in session table already available. Then it will check what is the stage of that particular session. It is a free stage, it's a opening stage or active stage or discard stage, or it's a closing stage or the close stage. If it's a closing or closed, then this packet go toward the silo path. If it's in free, then it will go into discard. If it's opening, active, or discard, then it will reset the TTL timeout value. In case of discard, it will basically drop that packet here. Or in case of opening and active, your packet go towards the fast path. So if there is a session already, then it will go for fast path. Otherwise, it will go towards the slow path. Now, guys, remember one thing. Regarding this particular flow, we have to understand few things. So let's try to understand that first. So let me just go down a little bit. So, to understand the flow, first we have to understand session stage or life of a session inside your Palo Alto firewall. So, in your Palo Alto firewall, basically all the session IDs, generally they are in the free pool. Initially, they are in the free pool. And if you will go here in your Palo Alto firewall, if you run this command, show session all, See, there is only one session, but if you will type show session info, this particular device supports around 1,99,998 sessions basically in total, and all are in the free pool except one. There is only one session on my firewall, otherwise all are in the free pool inside my one of the data plane DP0. Okay, all session are in the free pool. So what happens if your session is in free pool? That time, this particular stage is known as init stage. Okay, then from init stage, your packet will go into the opening stage. From opening, it will go into the active stage. Active, then it will go into discard or closing stage. Then closed, then again free, then again init. So initially, all the session is in free stage. From free, it will go into init, then opening, active, discard, closing, closed, free, then again in init stage. Means this is the life from free to initializing, initializing to opening, opening to active, active to either it will go in a discard or either in a closing, then closed, then again into the free stage. And in your firewall, when you will run the command like show session all, either you will see the init stage, active stage, or discard stage. These are the stable stages. So only you will see these three stages in most of the time. Remaining stages like opening, closing, closed, and free. These are the transient stages. You will not able to see these stages. Okay, but they are there according to the behavior. Just remember. I'm not already I have discussed that, so I'm not going into that one. Just wanted to tell you something regarding this session only. Okay. So guys, as I have mentioned, what used to happen when we will receive a packet basically in your Palo Alto firewall. So your Palo Alto file, let's say we have a PC here and we have a server here and we have a firewall here. Ethernet 1 by 2, Ethernet 1 by 3 inside DMZ. 10.1.1.100 and 10.2.2.100. So what it will do, see we have sent this particular packet. This is the first packet, which is a TCP SYN packet. So when this SYN received by the firewall, so as I mentioned, it will extract the 6 tuple and it will make a client to server flow. In this client to server flow, we have a source IP address, which is 10.1.1.100 and source port 1035. Destination IP address 10.2.2.100 and destination port is 22. Layer 3 protocol number is 6. Source zone is inside. Now this particular flow is created, and as I mentioned, it will run the MD5 hash on this. It will get one flow key. This flow key is known as flow key 1. And this particular flow key, it will basically store into the database called MongoDB. In this database, it will put this particular entry, and when it will create this particular flow, and it will check into the flow table because it's a first packet, so we are not having any type of flow. So now what it will do, it will basically get one session ID. It will get one session ID, let's suppose 100 from the free pool. Okay, it will get one session ID from the free pool. In this session ID, initially it is only having client to server flow. with this particular following flow key, and the state of the connection that is known as init stage. And this in the init stage, now your packet go inside the silo path, guys. And now in this silo path, basically it is going to perform so many checks. Now let's try to understand this particular silo path. In silo path or the session setup stage, this is the main stage, guys. And you know, most of the time when firewall do the packet processing is taken by this particular stage only, silo path. So the very first packet when it received, it will basically go for the zone protection profile check and the TCP state check. This is the first check performed by this firewall. Zone protection profile check, it will check, and if it will detect any type of anomaly or error, then it will basically drop that packet here right away. It will check the TCP state also on the packet, and it will basically, if it will failed or anything is failing, it will discard that packet right away. Otherwise, it will move further. And what it will do now, it will basically go for the user to IP mapping, user to IP mapping or user to group mapping check. Because you know, we have a user ID feature. When we will configure the user ID feature, there is a user to IP mapping is created in the management plane and also in the data plane. So that particular cache, it will check to get the username for that particular IP address to enforce the user based policies, right? And you know, it will only check, it will perform this lookup if we have enabled the user ID check in the ingress zone, because at the zone level, we have to enable that particular feature. Otherwise, it will move further and it will basically go for the app ID check. It will also maintain the cache for application identification. It will check app ID cache, identify application if matched with the destination IP, destination route, and protocol number. And you know what, it will store the destination IP, destination port, and protocol number in the app ID cache. And guys, this user IP user or user group cache or application cache, these are the CPU optimization processes. Because you know, if we will get the application detail in silo path itself, then we know we don't want to send our packet into the fast path, right? If we will get the user detail here, then we don't need to enforce the user based policy again and again. We do not need to enforce the captive portal based policies, right? So these are the benefit we will get here. Once these two checks has been performed, now firewall will go for the forwarding lookup. In forwarding lookup, it will get the ingress interface and the zone details, sorry, egress interface and zone details, virtual system for first client to server flow, and packet as per the interface type. Means now it is going to perform the routing lookup in actual. So in routing lookup, what it will do the lookup into the PVF first, like policy based forwarding. If we have a policy based forwarding, then it will basically make the decision to egress out this packet on the basis of PVF. Otherwise, it will fall back to your FIP table, which is a forwarding information base or the routing table. Okay. So generally it's a FIP table, but people said route table as well, but in actual it's a FIP table. Okay. So it will perform the FIP table lookup here, and it is doing this forwarding lookup just to get the egress interface and the egress zone, which is DMZ in our case. Just to get these details, it is doing this lookup. And if we have not found any type of route or PVA policies discarding this packet, then this particular packet is dropped here as well. And guys, if your packet is dropped by the forwarding lookup, then also you will not get any type of traffic logs. Okay, you have to only check this thing with the help of either you can use the test routing fib lookup command, either you have to check the global counters and you will get your answer. In case of layer 2, it will do the lookup into forwarding database. Okay. Now, after the routing lookup, after getting the egress zone and the egress interface, or the forwarding zone and the forwarding interface, it will basically go towards the net policy lookup. In case of net policy, now it will check is my traffic is matching the destination net rule. Because you know, if your destination IP will change, if your destination IP will change, then guys, what will happen? Your egress interface may also get sometime may change, right? Because now your packet will have a different destination IP. Now you have to do the look again, you have to do the forwarding lookup to get the egress interface and zone details for the this particular destination net IP address or the translator IP address. If no, then it will basically go for the authentication policies. Just remember one thing here. Here guys, in your net, basically it is just doing the net policy evaluation. It will not do the translation. Net translation is not happening. It just do the evaluation, means it will just said net rule number 3 is matching. That's it. Means only it will do the evaluation because your actual net is applied in the fast path. Your actual net is applied in the fast path here. I will tell you the reason. Don't worry. And after that, your packet go into the authentication policy lookup. Authentication policy lookup means these are the user-based policies. It will basically send the captive portal. And there is a one daemon called L3SBC who will involved to send this particular captive portal details towards the user. Means here it will enforce the authentication policies. Then it will move further and now it will basically go and check for the DOS protection policy lookup. And it will do the DOS protection policy lookup for the pre-net IP and post-net zone. So there is a concept of pre-net IP and services and post-net zone, and we will discuss in depth in your live sessions. Now it will check what type of DOS protection policy we have configured. It is an aggregate one or it is a classified one. It will check these threshold and it will basically discard the packet if there is a DOS attack is happening. If no, now your actual security policies, whatever the security rules, so I can say ACLs, we will configure. It will check here. It will do the security policy lookup. It will use the pre-net IP address, post-net zone details, application set to any, URL category set to any. Just remember guys, in your slow path, your application will not check, your application based policy will not check, and URL based policy will also not check, because these are the layer 7 features, and layer 7 features done by the Jaguar chip, and we have a dedicated app ID stage and content ID stage where your app based and URL based things happen. Okay. So here it will do the normal lookup on the basis of layer 3 and layer 4 information. Layer 3 means source IP, source port, destination, source IP, destination IP, layer 3 protocol number. Layer 4 information means your source port, destination port. It will do the lookup on the basis of that information. It will skip any rules with action not set to allow. If the application or URL causes the match, means if there is a application or URL is matching, then it will basically skip these for now. If not configure rules match, if like there is no rule match is happening, then it will have a, by default we have a two rules, interzone default and the intrazone default rule, which will basically deny the packet or the allow the packet. So if your intrazone is matching, intrazone, then it will allow the packet. If interzone is matching, means if your traffic going from one zone to different zone, then it will deny the packet. Let's suppose there is a one rule which is matched and the action is discard. Let's suppose there is a one rule match happens and where we have an action which is deny or reset server, reset client, or reset both, then this packet will be discarded right away. And if your packet is discarded by these rules, now for that only traffic log is generated. And in your monitor tab in log section, you can able to see the log here. If this rule is not matching, if action is allowed, which is yes, then your packet go here. Now let me go down a little bit. Now what will happen? Now it will create and install the session into the session table. Flow another session information into the session table. It will create two flows, client to server and server to client. Source IP, source port, destination protocol number, source zone, and server to client also source IP, source port, destination IP, destination port, protocol, and source zone. See, tell me one thing, guys. See, client to server we will get easily, but how we will get the server to client? Server to client also we will get easily because the source IP we have to put into the destination IP. Destination IP we have to put into source section. Destination port we have to put into source port, and source port we have to put here in destination port. Layer 3 protocol number remains same. Source zone we will get from the lookup which we have did into the fifth table or routing table, right? So that's how it will make both the flows. It will make both the flows here, guys. Just remember, client to server and server to client. And you know, one flow key we are having for this flow key one and another flow key we have for this. So guys, we have a only single session ID. Let's suppose 100. It is having two flows keys, server to client and client to server. So we always have a two flow keys for a session. Just remember. And let me also show you this here. Show session all. Oh, we don't have any session because it was just a dummy session we will be having previously. That's why. So interface management. Okay, I think I do have IP address on my interface. Let me just try to ping this IP address, okay, from my main PC. So at least there's a one session will create. But I'm not sure it will happen or not. Yeah, it's working. Show session all. We have at least one ping session. Let me just open this. Show session ID 94. And now you can see here we have a two flows here. Client to server and server to client. Zone is similar because it's a host only traffic, guys. This traffic destined towards the Palo Alto 5 interface. So you know they have source here 191.61.9 become destination and this destination becomes source. Zone is outside only because it's an intrazone traffic. It stays in it. This is the destination port and source port detail. This is the protocol number and all. Okay, so that's how they will basically create these two flows. So we have a two flow keys. Just remember always. Okay, now after that, guys, they will basically go and check for the TCI policies like tunnel inspection based policies based on source IP, destination source and destination zone, source and destination address and source users. They will check which protocol they are using for the tunnels like GRE, GTPU, IPsec non or non-encryption or VXLAN. If yes, then what is the maximum tunnel level? Because firewall can able to do the decapsulation maximum of 4 tunnels. If no, reach no means perform the tunnel decapsulation, then it will put that packet again into the again in the starting here to the session setup for the actual IP processing here. Okay, if no, then this particular packet go here and it will basically install the session into the session table. See, So your session gets installed into the session table after completing the silo path check or the session setup states. Once it will complete that stage, it will basically put that session detail into the session table. It will basically change the stage like active, reset the TTL value because each and every session has a time to live or timeout values. If my rule is drop discarding that packet, then it will go in a discard state. Otherwise, if in opening or active, it will go towards the security processing or fast path. And your fast path basically, they will again do the layer 2 to layer 4 processing. They will apply the net if applicable. Forwarding lookup, again, they used to perform the forwarding lookup for all client to server and server to client packets. But here we have already done, right? But here also they used to do, because now guys, whatever packet we will receive for this particular flow, it will not go into silo path. Silo path will be bypassed. Silo path will be bypassed. Whatever subsequent request and reply packet will come for this particular flow, each and every packet go for the fast path only. Silo path will be bypassed now. Because this slow path we are bypassing, that's why we are applying the net here, because net ultimately we have to do for each and every packet, right? So that's why we are do the net, we are doing the net translation into this stage, and also we are basically doing the forwarding lookup for client to server and server to client packets again. If there is a route change or zone change, then this packet will be discarded. Otherwise, your packet will go toward the SSL proxy. As this particular packet is basically needs to go through the flagged for, if is this particular SSL proxy flag is there in the session, because it's a first packet, so no flag, right? If there is a flag, then SSL decryption needs to be performed on the packet. Okay. If SSL decryption needs to perform, then what will happen? Your SSL engine come in a picture. So we will discuss in detail how this SSL engine used to come in a picture, because it used to extract the layer 7 information, then it will save that information into FPTCP segments. Then these particular FPTP TCP segments will fed back to the SSL chip, then SSL chip perform all the SSL related task. No, as application is identification happens. If no, then your packet go towards the app ID. If app identification happen yes, then your packet go towards the content ID stage or CTD. Now in app ID, I'm going like bit fast here for app ID. So you know when your packet go into the app ID, it will check the app override policies. If matching, then it will directly jump that packet here. Security policy lookup with application. If no, then it will perform the pattern based app identification. Means here your actual application identification happens. Means this particular packet now go through with the app ID check. So it will basically check the app ID signatures for unknown decoders, known decoders, heuristics, all these things it will perform, and we will get the application. Once we will get the application, it will update the app ID cache, and it will again now do the security policy lookup. Again, it will enforce the security checks with regards to that application. What is the action we have set? If the action is rule is matching and we are basically denying that packet, then your packet will go in a discard state right away. If rule match which allow, then it will check on this rule we have configured the layer 7 profile. If yes, then it will basically add that particular layer 7 flag, apply security profile flag on the session. If no, then it will basically move towards the QS policies. If your application identified as SHS or SSL, then it will go toward the decryption policy lookup. If yes, then it will check the decryption exclusion case. If your packet is not in the exclusion case, then this packet now again go back to the SSL for SSL proxy, SSL decryption processing. Okay, so from, because we will always do the decryption for SSL based packets. And how we will know this traffic is a SSL based traffic? Because first app identification happens. Okay, just remember. Then your packet go into the CTD engine where your signature matching happens. Protocol parsing, decoding, content matching against signatures, internal application detection, right? If there is a application shift is happening, then your packet again go inside the app identification. If no, then thread is detected. If yes, if there is a thread, then it will basically apply the security protections. It will discard the packet. If rule action is alert to allow, then if we have done the SSL decryption, then it will do the re-encryption of these packets. And now that packet go inside the ingress stage or the forwarding stage. In forwarding stage, basically it will check packet forwarding and processing. It will use the ingress interface to get the forwarding domain, do route switch or wire forwarding, packet ingress process. It will do the fragmentation if needed, apply the QoS shaping if we have configured. If your ingress stage is the tunnel interface, then your packet basically go inside, go here and will for IPsec packet, it will be encrypted, hash added and encapsulated inside the ESP. For SSL encrypted and hash added, for GRE hash added and encapsulated, then packet go for the final transmit. Okay, so this is what the exact packet flow, guys. I have not went on a too much details for today because it's just a demo lecture. Uh, I generally needed around 3 or 4 hours to complete this particular entire packet flow because I have used to basically try to cover from here as well, like how the packet processing is happening, how your TCP SYN plus ACK is processed. You can see we have received packet into the ingress stage. And this time, there is a session, there is a one active flow has been found. This session is directly going toward the fast path. See, in queue to the fast path, receive packet on fast path. Now slow path is bypassed. That is a like a stateful inspection only. Okay, so we will discuss in detail in your live sessions. And guys, one more thing. Let me ask 2 3 questions, and after that I'll give a chance for Q&A. Guys, tell me one thing. We have this PC here, PC1. We have this firewall, and we have this server. Let's suppose this server is hosting the service on TCP port 443. Okay, and the IP address is 10.2.2.100. Here 10.1.1.100. This is Ethernet 1 by 2. Let's say this Ethernet 1 by 3, DMZ, and inside. Now tell me one thing. When this PC will communicate with this particular server, so when this communication will happen, right? So when when this communication is happening, it will send the very first packet, TCP SYN. SYN is processed by the firewall. Go to here. Now this server will give the reply. This is the second packet, TCP SYN plus ACK. Then we have a third packet, which is TCP acknowledgement, and that's how they will complete the TCP three-way handshake. After completing the TCP three-way handshake, we will get the first packet, which is client hello, because they will start the SSL handshake, right? From the server side, we will get the server hello. Then you will get the server certificates. Now, guys, I want to ask one question. Packet number 1, 2, 3, then this is your fourth, fifth, and sixth. Like, tell me one thing, your layer 7 information is available on which packets? Starting from which packet your layer 7 information is available? And also, this app ID, and content ID related things when it will start. It will start from first packet itself or from which packet it will start. Just write on the chat if you know that answer. So guys, no one knows that one. I got a correct answer. It will start from the fourth packet onward. So guys, just remember why I have just highlighted this, because in today's example, I have told like I have explained with regards to first packet cell, right? Your TCP SYN plus egg and egg. These two packets, they will not go inside the app ID and content ID because they are not having any type of layer 7 data. Just remember. Okay. So your app identification and content identification started from the client hello itself. Just remember. Okay. Okay, guys. So now let me just tell you one last thing, and after that, I'll just stop. Guys, as I have mentioned, this particular batch I'm starting from 8th of December. We will go through with the in-depth training of Palo Alto Firewall, then Panorama, Expedition tool, then API. And guys, for this training, I will use my hardware firewall, which is PA40. I will use the switch, which is 3750, and also I will use couple of VMs, but these are the VM300 devices. For doing the lab, okay, and it's a weekends batch, and total duration of this training is 3.5 months. Your classes will happen Saturday and Sunday. And guys, cost of this particular training is 12,000 for Indian students and 200 USD for international student. And that cost is only valid for 2 days, today and tomorrow. After that, that cost will go at 16K for Indian students and 250 USD for the international students. Thank you very much guys for joining this demo. Now, let me give a chance for the questions.